Hello all. In this video series, we are going to discuss graph theory, how we can represent a problem of computer science in form of graph, how to apply various theorems, how to analyze a graph, and how to come up with the solutions. So the subject is graph theory with applications to computer science. So here we will not see how various theorems of graph theory has been proved, but we will see how the various theorems is to be applied in various problems in the computer science field. For this video series, mainly I'll be referring one book, that is Graph Theory by Narsinghdeo. So let's get started. So the graph here is not the graph that is bar graph or pie chart or those type of graphs. But here a graph means a graph which has vertices and the edges. Like in this diagram, you can see this is a graph which is having 4 vertex and this is having 4 edges. So this is how the problem in the computer science is to be represented, and wherein we can apply the various solutions or various theorems. So broadly, graph is categorized into two categories, that is undirected graph and directed graph. From here we are going to discuss the undirected graph, and later we will see what is directed graph. Okay. Mathematically, a graph is defined as collection of two sets, that is set of vertices and set of edges. So a graph is nothing but the collection of V and E, where V is the set of vertices and E is the set of edges. And if it is undirected graph, then each edge can be represented by pair of two end vertices which can be unordered. Okay, so that is a graph will have two sets. One is the vertices set, the other one is the set of edges. Okay. And this each edge is nothing but the collection of unordered pair of two end vertices. So that is, an edge is defined by its two end vertices. So for this graph, okay, let us say this graph is G. In its vertex set, there are 4 vertices, that is W, V, U and Z. And in the edge set, there are 4 edges. And how to write those 4 edges. Okay, so those each of the edge, as I said, as per the definition, can be represented by using two end vertex. So how each edge will be represented? Each edge will be can be represented by two end vertex. That is, let us say one edge is UV, the other edge is VW, the next edge is VUW, the next edge is WZ, and so on. So before proceeding further, we will see some terminologies, and let us consider this graph. So in this graph, there is an edge. Okay, there is an edge, and this edge is having same starting vertex as well as end vertex. So that is an edge, that is E1, which is having same starting as well as end vertex, that is this one. Now this type of edge which is having same starting as well as ending vertex, it is called self-loop. There is another type of edge in this graph, that is parallel edge. Now parallel edge is when we have more than one edges having same starting vertex as well as ending vertex. So that is called parallel edge. So you can see here that this edge E5 and E4, these two edges are the parallel edges because they have same starting vertex as well as they have same end vertex. So these are some of the types of graph. Okay. So if we are saying simple graph, it means that graph which does not have any self loop, neither parallel edge. Okay. Now in a simple graph, there will not be any self loop and parallel edge. So this is an example of simple graph. A multi-graph is that graph which has parallel edges. It may or may not have self-loop. General graph is a general graph which can have parallel edges or self-loop. So simply if I say graph, so then it will be a general graph. These are the different names that we can use to call graph or vertex or edges. A graph can also be called a linear complex or one dimensional complex. A vertex can also be called as node or junction or point, zero cell or zero complex. Similarly, an edge can be called as branch, a line, an element, one cell, arc, one simplex. So these are the different names.